I wanted to create a small command utility in Kotlin, but I also wanted it to be native, so I created a command line program to do just that. But I didn't want to use if-else or whens, so I used reflection for that. But I also wanted to make sure that all the tests ran successfully, so I created unit tests for that, and I ran them, and they were all successful. But then I ran the utility via the command line, and it failed. But I did test it for everything, so why am I now getting all these errors? The error we are looking at tells us that our executable, generated with native image from our GraalVM distribution, cannot find class add. When we want to generate our executable file, the builder will scan for all possibilities and paths for our code to run. Reflection hides those pathways, and because none of them is declared, the builder cannot determine on its own which code is going to be used during runtime via reflection. If pieces of the code are not detected by the builder to be used, then they are treated as dead code and do not become a part of the final assembled executable. This is the reason we get a class not found exception. But the builder generates metadata that is also responsible for defining how we are building our executable. Fortunately, this way we can define which of the seemingly not used codes can actually go into the assembly. But our metadata is not complete yet. First, we need to run Java inspection in our code. Now let's go through a few of the important aspects of our test project configuration. We are coding in Kotlin, and therefore we are highly dependent of the Kotlin standard library. And this is the reason why we need to make sure to add the Kotlin standard library path to our class path, or add it as an input parameter for our class path switch. And that is the role of our standard library variable, which we've called stdlib, that we use as an input parameter of our class path switch in every command where it's needed. And here above, I have configured it to use Kotlin standard library 1.9.20, but this you would need to configure for your own system wherever you have one of the Kotlin standard library versions. To perform code inspection, we need to make sure that the agent is discoverable. This can be done in Linux, for example, by adding the lib path of our GraalVM distribution to our shared library system variable, which in Linux, this is known as ld library path. So now let's go through our example and finally reach our perfect executable native application. So if we go to the main function of our code, we can see that I am using 4 parameters. The first parameter is the class name, the second is a method name, and the third and the fourth are the input values. I'm using reflection to get the class and then to get the declared method. We've got 2 options, and the options are add and join. Add is the sum of the 2 values, and join is the concatenation of the 2 values. And to start off our example, let's first start the compilation of our Kotlin sources and generate the bytecode. It has created 2 compiled classes, the add and calculator, and in metainf we can see that there is a main Kotlin module therein. We can already create one version of our native application. However, this version will not work. And the reason is because we are using reflection, our add class is not discoverable. And we can see this when we run the compiled native Kotlin only script. Once this version of the native application is generated, we can test it, and as expected, the add class is not found. To make this add class discoverable, we need to run Java class inspection. And for that, in this command, we are applying a switch called agentlib. And in this one is native image agent. In this one, we'll generate JSONs that are part of the metadata responsible for creating future native images. And we are setting the output to metainf/native image. And plus, at the end, we are adding one way of running this application. With this, the inspector will generate everything for us, but will not be aware of the join function yet. Add will help us. Starting with add, we can easily complete the JSON configuration. When we run this command, it will actually execute our program in the way that we have defined here. And finally, as output, we get the actual result of the sum, which is in this case 1 + 2 is 3. But in the background, it has already created a native image folder, and in the image folder, it has created all of these files. The one that we are interested in is reflect config. And reflect config has already the class add, it has the method add, and the parameter types. So we know there are 2 integers. But what about join? If we try to generate now a native image with this configuration, it will still not work. Half of it will add, but the other half will not. Let's try that. So now let's run test Kotlin native, which tests our application by using the 2 possible configurations that we have at the moment with the same values. Call to add and the call to join. We can see that add has executed perfectly, but join not yet. And in the exception, our application is telling us that this method just doesn't exist. Simply put, it has not been made a part of our application. So let's do just that. We only have to go to reflect config JSON file, And because they are very similar, it's very easy to just add join. Let's run our native image command again with our scripts, and let's make the final test. Everything worked. So let's have a look. The add is working, 1 + 2, 3, and the join is also working, 1 concatenated with 2 is 12, and we are done. This is the manual way of creating native applications. With the help of IDEs like IntelliJ or Eclipse or other IDEs, we can of course skip some of these steps because they are done in the background for us. I made this video to share my experience with native code in GraalVM and building applications with Kotlin, and provide you an insight on how can you work with GraalVM purely using the command line. If you enjoyed this video, please give it a big thumbs up. Don't forget to leave a comment in the comment section, smash that subscribe button, and because one point of interest of using GraalVM in our applications is to make them more efficient, you might be interested in knowing about reactive programming and how to build a reactive application. I have created a 3-video series about how to build a reactive web application using coroutines, and you can find it right over here.